what we're going to be working on today is ratios and proportions, part 1. So that's the first one we're working on. And so let's consider the first part. So a ratio is the comparison of two like quantities. Can I still keep writing? Yeah, quantities. Oh, yeah. Cool. One thing we always have to consider is that the terms of a ratio must be expressed in the same units. Go. For example, let's look at our first example. Where this is 13 millimeters and this is 9 centimeters. Okay, so first, before I can even compare them, I have to look at them. Are they the same units? No, right? One of them is millimeters, the other one is centimeters. So, at this point, what we have to do is we have to make sure that we get into the same one. And so, we have to remember, oops, gotta switch. 1 centimeter equals how many millimeters? 10 millimeters.
10.
Yep. So one thing that we are going to have to make sure we know is, and I'll get you a copy of this, is the metric system and some of the unit conversions. Because as you get some of the projects, they might be in different units, and you just have to make sure you get into the same one. So from here, we can multiply by 10. And what we really have is 90 millimeters. So now I can actually express this as an actual ratio. And so what I have is 13 to 90. And that's one way of expressing a ratio. Or we can express it as this. Cool. All right. So let's look at the next one. So for the next part, let's consider simplifying ratios. So, just like the one before where we had 13 to 90, sometimes we might get something like that. But sometimes we might get something that perhaps says the ratio 2 to 10. And we want to simplify this. So, we know that we can rewrite this as 2, 10. We can also rewrite this as a fraction, 2 over 10. And now that it's a fraction, we just need to simplify it. So what's the number that goes into both of them?
1, 5.
Yep.
2.
2, perfect. Which is 1, yep, over 5. So what is my simplified ratio?
23.
1, 2,
5.
5. So whenever you see the symbol right here, it just means the same. That's just what it means. This, whatever is happening on the left, is the same thing as what's happening on the right. Cool. Any questions so far on any of this?
No.
All right, so let's look at the next one then. So now that we have seen ratios, let's look at a proportion. I know, right? I was struggling a little with that one. Okay, so let's look at a proportion. So, for a proportion, So proportion is an expression that states the equality of two ratios. For example, consider this. The ratio of 3 to 4 is the same thing as 6 to 8. Is that true?
Yeah.
Yeah, because think of it this way. If we rewrite this as a fraction, we got 3 over 4. If we rewrite the one on the right as a fraction, we got 6 over 8. Can I simplify the one on the right? I can simplify it by 2 again. And so what I have is 3 over 4. So are they the same thing? Yep, they're both the same number. I would have just should have just done it that way. There you go. Alright, you know what? I'm just gonna box it. They're both the same thing. So that's what a proportion is. More importantly, as I look at this, what a proportion actually allows me to see is, as I'm building something or I'm designing something, I can have the real thing built already, right? So if I'm building a house, oh, I see. So as I'm building this house, and I need to be able to show this to, hey, like, this is how big the house has to be, this is how it needs to be. Yep. So as I'm building this, I actually need to make sure that whatever I'm building, I'm able to show it, but at a smaller size. Because I want to show what my product is going to look at the end. And so with the proportion, that's what it allows me to say. What I can say is, whatever this size is for my smaller design that I'm showing you, it's actually proportionate to how big it's really going to be. And that's the reason why we use the ratios and proportions, just to be able to show that. I can always come up with something that is small for everybody to be able to see, and then we can actually translate those small sizes into the actual real thing. Cool. For example, if I'm saying this here, let's look at our door frame. And so perhaps here in this one, we're gonna say is about 3 centimeters. To, I don't know. Let's say, how big do we want this to be right there?
5.
5? Needs to be a little bit taller. Usually that count.
28.
That's a huge person. Tall. That's a really tall person.
7.
There you go. Yeah, 7 centimeters seems reasonable. So if I know this is 3, this is 7, and then I go and I tell you, you know what? This right here, and the actual size, we're gonna say is about 12, 24, 36. It's about 56 centimeters. Well, I need to find out what this is, so I can actually just set that out as X. And sorry, that doesn't look like a 56.
X is back.
Yep, and we want to find this unknown right here. So what I can actually do is, I know that this right here is actually proportionate to the bigger one. So I can just set them equal to each other. How tall it is over how long it is equal to how tall it is on the other one over how wide it is. So we're comparing them by height and by how wide they are. And so we just have to remember to make sure we keep the same units where they are. So the height was 7, the width was 3, the height was X, the width was 56. Then now from here, I can actually just work this out now. We cross multiply. Three times X is just 3X equals 7 times 56. And so what is 7 times 56? 392. And now I just divide it by 3. So what do I get?
3x equals 300.
150. Wait, 100 and what?
30. Yeah. About 130. And like 2/3.
So what was it?
130.
30? Okay, cool. Yeah.
Like 2/3, but that doesn't matter.
Cool. Did it have any decimals?
Mm-hmm.
Cool. Now, as we work through any kind of designs here in the class, 2 decimal places will be fine. But you do need to make sure you keep your decimal places, because 131 and 129 in engineering are very far from each other. So we want to make sure we get as precise as we can, and usually a 0.1 margin of error is fine. I mean 0.01 is usually fine. So cool. Awesome. Alright, so for the following problem, just give it a try. Okay, so in this case, let's think about it. So we know that we have 11.58 gallons, gasoline at 21.89. So let's see, we can write that as 11.58 over 21.89 equals, and then we do now the other ones. So we got 17.32 gallons, and we're gonna divide it by X because we don't know what the price of that one is. So now we can cross multiply. $11.58 equals 21.89 times 17.32. 379.1348. And now we just divide by 11.58. So divided by 11.58, we got 32.74 cents.